Good evening. My name is Alfred Sejas, and I'm doing the critical thinking test for week 2 of instrumentation and biomedical machines, devices. And I'm doing number 14, and it asks to describe the fundamentals of an ECG recording, how it works, from patient to readout to the machine, and to give the procedure. Basically, the heart is a muscle formed in a way that allows it to act as a pump for blood. The heart pumps blood when the muscle cells making up the heart wall contract, generating their action potential. This potential creates electrical currents that spread from the heart throughout the body. The spreading electrical currents create differences in electrical potential between various locations in the body, and these potentials can be detected and recorded through surface electrodes attached to the skin. The waveform produced by these biopotentials is called the electrocardiogram. That is a written record or graph of a cardiac electrical potential waveform. Okay, here I am again. And I'm now going to do the next question, question B, which asks for the main components of the ECG, what they are, what they're used for, how and where they're connected. And it goes like this: the standard lead system. In standard ECG recording, there are 5 electrodes connected to the patient: the right arm, or RA, left arm, LA, left leg, LL, right leg, RL, and the chest. These electrodes are connected to the inputs of a different buffer amplifier through a lead selector switch. The recording obtained across different pairs of electrodes results in different waveform shapes and amplitudes. These different views are called leads. Each lead conveys a certain amount of unique information that is not available in the other leads. And we have a figure here, figure 8.2, that shows the electrical axis of the heart that is examined by 6 of the standard leads. And this would be the picture right here. And it shows all the leads. And it looks a little backwards there on the video, but you'll get the idea. And that's pretty much how it works. Okay, so the last question, question D, asks for the main causes and solutions for the main problems or malfunctions that the ECG may have. In other words, troubleshooting steps. So one symptom, as described here in the book, is the machine runs, but the thermal tip stylus does not write or writes very lightly. Possible causes include 1. Too little heat on the stylus tip, and 2. Insufficient stylus pressure on the paper. So troubleshooting steps for this, to remedy this, would be 1. Using an insulated probe, such as a screwdriver, gently press the stylus onto the paper. Another solution would be, if a dark line appears on the paper, the problem is too little pressure. But if no dark line appears, the problem is not enough heat. So, solutions would be: 1. For no heat, check the heater voltage at the stylus wires. For no heat, check the heater voltage at the stylus wires. If the voltage is correct, then change the stylus. If the voltage is not correct, then refer to the service manual for troubleshooting. Solution number 2. Adjust the stylus pressure. Do not guess at the proper pressure, as different models may require between 2 and 20 Gs. Use a stylus pressure gauge and refer to the manufacturer's service manual for the correct value. On some models, the pressure must be made at a specific heater voltage. So another problem that the machine may face is a smeared trace, which would look like figure 826. A. The smeared trace would look like this. Possible causes: worn stylus or incorrectly loaded paper. So the troubleshooting for this would be check paper loading and, if proper, check stylus for wear, pitting, or other irregularities. And the third symptom, the third problem, would be poor recording. Possible causes: electronic or mechanical problems, bad lead switch or input connector, bad patient cable or improper connection to patient. And the troubleshooting for this, the steps would be: number 1, place lead selector switch in STD. Short all electrodes together and press the 1 millivolt cal button. Number 2, if normal calibration pulses appear, then the problem is the connection to the patient. 3, if problem persists, repeat step 1 using a patient cable that is known to be functional or a deadhead plug. In other words, ECG connector with all pins shorted together. If the problem clears up, then replace the bad patient cable, but if it persists, the fault is inside the machine, in which case you would refer to the service manual for troubleshooting. And that would be it. Thank you very much.